Hello everyone, and welcome back to the Fluctus Channel. The F-22 Raptor was built to dominate the sky by combining stealth, supercruise, violent acceleration, and extreme agility in one airframe. Only 195 were produced in total, including test and operational aircraft, which immediately makes every jet feel rare before it ever leaves the ramp. At roughly $150 million a copy by Common Program Era shorthand, the aircraft became one of the most expensive fighters ever placed into frontline service. Yet the number alone is not what makes the Raptor feel exceptional. It is the way the design concentrates power. Two Pratt & Whitney F-119 engines, each in the 35,000-pound thrust class, feed a fighter capable of supercruise, sharp nose authority, and brutal changes in direction. The wings, tailplanes, flaperons, rudders, and thrust vectoring nozzles all contribute to that aggressive personality. On the flight line and in red flag-style operations, the aircraft already looks coiled even while standing still, as though the shape itself was designed around the idea of sudden violence in the air. It remains a fighter whose features are inseparable from its purpose. Strike first, turn harder, climb faster, and always leave the opponent reacting too late. The Raptor's aggression becomes real during pre-flight, where the machine is still quiet, but the workload is serious. Crew chiefs walk the jet, inspect the skin, check access panels, landing gear, inlet areas, control surfaces, and the edges that help preserve its low observable shape. Pilots climb in and begin cockpit checks. Powering displays, confirming navigation, communications, and flight control logic before the aircraft starts rolling. By the time the canopy closes, the fighter is shifting from an expensive object to a living system. That transition matters because the F-22's most impressive maneuvers depend on absolute trust in software, engines, and flight controls working together. Then comes the takeoff, and this is where the pilot starts testing the limits of the Raptor's aggressive design. The aircraft's thrust-to-weight relationship is one of the defining reasons it feels so abnormal in the air. With two F-119 engines driving it forward, the fighter can pitch steeply and keep climbing hard, turning runway length into altitude in seconds. In cockpit climb sequences and vertical demonstration profiles, the jet seems to stop behaving like a normal airplane and start behaving like a controlled rocket. That is the logic behind the famous near-vertical departure style often associated with the F-22. It is not a novelty trick. It is a glimpse of what happens when huge thrust, a light enough configuration, and flight controls built for instability line up at once. But raw climb is only part of the story. The real pressure arrives when the aircraft begins piling on G. High-performance maneuvering forces the pilot's body toward blackout, which is why G-suit testing matters so much in the Raptor world. The suit is not just a comfort item. It is part of the aircraft's combat usefulness, compressing the legs and abdomen to help keep blood where the pilot needs it during hard turns and rapid pullouts. The faster and harder the airplane can move, the more important the human support system becomes. Once airborne in a full demonstration routine, the Raptor starts revealing how all of its surfaces work together. Thrust vectoring nozzles change the shape of the turn. Tailplanes and flaperons bite the air. The nose swings with unsettling authority. The fighter can pitch aggressively, recover cleanly, roll fast, and move through high angle of attack attitudes that make more conventional fighters look restrained. That is what people mean when they talk about the F-22's aggressive design. It is not simply fast. It is designed to remain controllable in parts of the envelope that feel confrontational. Supersonic ability deepens that advantage. The aircraft is famous for supercruise, the ability to sustain supersonic flight without afterburner, which changes how it enters and leaves fights. Instead of treating speed as a short burst bought with enormous fuel burn, the jet can maintain pressure with less drama and greater efficiency. That means the Raptor can arrive quickly, reposition quickly, and preserve more of its energy for the part of the fight that matters most. All of this still depends on the engines delivering exactly what the airframe expects. That is why engine hush-house testing remains an important part of the process. Maintainers run and certify the F-119s in controlled conditions, verifying that the same power responsible for the aircraft's climb, acceleration, and control authority is healthy before it returns safely. In the end, the F-22's limits are tested every time the pilot pulls hard, the body strains against G, the jet points uphill, almost vertically, and the engines keep forcing the aircraft into parts of the sky that feel unreasonable for a fighter to occupy safely. The F-22's aggression is not only aerodynamic, it is also hidden under the skin. Stealth on the Raptor depends on shaping, internal carriage, and the condition of its low observable surfaces, which is why the coating process matters so much. Specialized work on those surfaces is not decorative. It helps preserve the aircraft's radar signature and keeps the jet from surrendering one of its greatest advantages before the fight even begins. A stealth fighter that cannot maintain its skin eventually stops being the fighter it was designed to be. That matters because the Raptor's weapons are meant to stay hidden until the last possible moment. The jet carries missiles internally, allowing it to remain cleaner and harder to detect while still bringing firepower into the fight. Weapons loading, therefore, becomes a careful process of marrying stealth with lethality. Load crews handle different munitions types and fit them into the bays that let the fighter remain outwardly smooth while storing destructive force inside. The point is not just to carry weapons. It is to carry them without giving away the aircraft's shape. Once airborne, that hidden firepower becomes part of air combat training. In pursuit sequences against aircraft such as the F-15E, the F-22 demonstrates how stealth and maneuvering combine. The opponent may be highly capable, but the Raptor was built to see first, position first, and fire first. Dogfighting training still matters because no pilot wants to trust theory alone. The aircraft has to prove it can hold angles, manage energy, and stay lethal once the geometry tightens. Missile firing turns the theory into a shot. During weapons system evaluation program activity at Eglin, F-22s fired AIM-9 missiles, proving not just that the aircraft can carry short-range weapons, but that it can employ them under evaluation conditions with the same clean, sharp violence suggested by its design. And because even the Raptor cannot remain everywhere on internal fuel alone, aerial refueling closes the loop. When KC-10 tankers refuel F-22s in formation, the fighter's stealth and weapons combine with endurance. That is the real point of the whole system. A jet that can stay hard to find, carry internal weapons, and then keep ranging outward because tankers extend the fight beyond what the aircraft could do by itself. The internal weapons arrangement also shapes how the airplane fights. Bay doors open only briefly, release the missile, and close again, so the jet does not spend any longer exposed than necessary. That quick sequence is part of the F-22's personality. Appear late, strike hard, and disappear back into a cleaner signature. In practice, the Raptor is not a noisy weapons truck. It is a stealth predator, carrying enough force to end the engagement before the other aircraft fully understands the danger. That is why stealth maintenance, internal loading, missile employment, and aerial refueling all belong in the same story. Together, they turn the fighter into something far more dangerous than speed alone ever could in modern air combat. What keeps the F-22 exceptional is not only what it does in the air, but what happens after it lands. The aircraft's reputation rests on a maintenance culture that treats every sortie as the beginning of the next one. In austere refueling scenarios such as Pacific Iron 2021, crew chiefs used the experimental Star Cart to help support the jet away from the comforts of a fully built ramp. That matters because the future fight may force Raptors to recover, refuel, and relaunch from more improvised locations than the old peacetime model ever expected. Routine maintenance on the fighter is dense and methodical. Panels come open, technicians inspect systems, service components, and work through the hidden details that keep stealth, avionics, hydraulics, and propulsion all aligned. Nothing about the process is casual, because the F-22 is unforgiving of neglect. Every sortie asks a lot from the airframe. Maintenance is how the force keeps asking. The gun system adds another layer. The Raptor's M61, a 2 Vulcan, is mounted internally, and armament crews have to inspect, service, and repair that system so the aircraft's close-range punch remains dependable. The weapon may be hidden most of the time, but hidden does not mean simple. its reliability still depends on careful work on the ground. Avionics and pilot interface matter just as much. Installing and refining systems such as the head-up display means preserving the pilot's ability to fight the airplane at high speed with clear information directly in view. If the jet is meant to exploit seconds of advantage, then anything the pilot sees late is a liability. And then there is history. In 2012, the final production F-22 landed at Joint Base Elmendorf-Richardson in Alaska, marking the end of the manufacturing run. That moment gave the aircraft a strange status. No more would be built, which meant every existing Raptor became more important. Since then, keeping the fleet relevant has depended on maintenance, repair, and careful stewardship. The F-22 remains aggressive because the people behind it refuse to let that aggression fade on the ground. Even engine support ties back into that effort. Ground crews do not wait for a dramatic failure. They inspect, test, troubleshoot, and certify systems while the aircraft is still on the ramp, because a fighter this rare cannot afford unnecessary downtime. In practical terms, sustainment is what turned a closed production line into an enduring combat fleet today. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.